Hey everyone, today I want to talk about visualization engineering. Recently, models such as Nano Banana and ChatGPT have added capabilities to create very clear and deterministic visuals. What I mean by that is not just creating an image that looks nice or an image that looks very polished, but a very specific workflow diagram, a very specific slide, or a very specific infographic that is based on very structured deterministic input. Let's see what I mean by that. Um, Initially, we when we worked with large language models, we worked with text either by typing or speaking, and the large language models responded. They gave answers based on what they know. They reasoned based on their knowledge and so on. But with capabilities that are now available as recent as a couple of months back, large language models are able to create artifacts um, from very, very specific inputs in a very, very predictable manner. They're evolving from conversational partners to um, assistants that can create very specific, very valuable artifacts, particularly visual artifacts. So the new models, whereas the old models created probabilistic strings of text, the new models are able to create very precise, very definite output based on a very clear structure. So what they do is they first take your text inputs, you can type it, you can speak it, and then they will turn them into very structured inputs to themselves, to large language models, and then generate reliable diagrams, maps, blueprints via visualization engineering. So why should product managers care about these new capabilities that are now available um, in large language models such as Gemini and ChatGPT? PM should care because now PMs have the ability, or product managers or founders of startups now have the ability to create artifacts that are not just AI features, but that are visual outputs that are reliable, repeatable, and testable. Now, in this era of large language models producing artifacts such as infographics or presentation slides or project plans or data visualization, it is the responsibility of the product manager to define the rules, define the frameworks, define the inputs that create these visuals, and own the reliability and testability of these visual artifacts. So the new product manager surface area looks like this. Output constraints. Yeah, LLMs can do a lot of things. So product manager should be able to constrain the to provide constraints, guardrails to the large language model about the artifact. If it is a slide, the PM should be able to say the slide should be in landscape format or portrait format. This font, this color, this image, and so on. And the product manager should be able to define the test cases that are required to test the outputs once the large language model creates these artifacts. And finally, the product manager it should be able to define how to verify if the large language model created an artifact based on a deterministic input, that is text or numbers from a particular system or a particular person. So the core thesis is as large language models start producing artifacts, product managers become responsible for engineering the rules that make those artifacts trustworthy. This is what I want to call visualization engineering. So the breakthrough here isn't better images, it's deterministic visual structure. It is not nice looking videos or professional looking images or icons, but it is a visual structure that is deterministic, that is predictable, reliable, repeatable, and maneuverable. So this is a very new capability in learning large language models. Until even 4 or 5 months ago, this was not possible. And I'm talking in January 2026. So until late 2025, this was not possible. Um, until recently, reliability of generated media, that is pixel generation, that means bitmapped images or raster images, which is photographs generally. Um, the reliability of producing a picture in a repeatable manner is very very low. I would say just 40-50% maybe, and the reliability of natural language responses is about 75%, depending upon your prompt. But the reliability of creating a structured visual output in an SVG format or it's a scalable vector graphic format is very, very high. So, which means what that means in a practical sense is that we can now create visual artifacts that are very, very reliable. And if we add some edit capabilities on top of it, it makes it very useful in a very and very practical for everyday use. So, image generation, that is, raster image generation or photorealistic image generation is a black box. It's probabilistic. You cannot easily edit or verify individual components unless you reprompt the large language model and try to modify it, and the reliability of that is not very high, at least not as of today. Whereas layout engineering is controllable. That means engineering a visualization of data or of text is very controllable. We can define, product managers can define very clear constraints. We can generate code based visuals. Every element remains deterministic. You can say this particular text should be this font, this size, this color, this icon should be here, and so on. We can inspect the logic paths. We can repeat visual schemas, and we can program interactivity if we as and when we build interactivity into it. um, so to demonstrate this, what I'm going to do is I'm going to create um, a journey map visual as an example. Now, this example could apply to project plans, um, data visualization, workflows, any diagrams. But I'm going to use a journey map to demonstrate how this new technology or this new capability of large language models works. So the this is a four-step process. First you can provide a narrative. um, for example, I can say, oh, my journey map looks like this. The user will log in, they will be authenticated, then this is an appointment scheduling use case. They will then pick a doctor, and then they will pick a appointment slot, and then they will confirm the appointment, and then they will log out. I can simply narrate it, just type the text, and then ask the large language model to structure my input in a way that it can understand. So it will then structure that input. It will make suggestions, and then it will create the structure and it'll then map the structure to a technical schema, which means make it very deterministic, and then create a very engineered visual that becomes the journey map artifact. And we'll see a demo of that. So the the future this is the future proof idea. Now, this isn't just for journey maps. It applies to system dashboards, diagrams, summaries, complex project plans. What we are essentially doing is we are essentially designing the logic of visualization, which engineers have done in the past. But with large language models, product managers can now do this by um, simply prompting the system. So that is the shift that is happening. Let's see a demo of this. So what I've done is I've created an app called a journey map builder. A journey, I won't go into the details of exactly what journey map is. So essentially, I want to provide some inputs, and then I want to create a journey map that a journey map that looks something like this, something like this. So that's what I want to do. So I am going to first start my journey map. I'm going to click on start creating your journey, and then um, I'm going to describe my journey um, as text. I'm not going to provide a very structured input. I've already described it here, so I'm going to copy it from here. So this is the same appointment scheduling journey that I described. So I'm going to describe that journey here very broadly, and then say extract the exact steps out of this journey. And what the large language model is able to do is it's able to extract the exact steps out of the journey, which will then become the input for the visualization. So I've added some capabilities to edit. If I have to make some fine tuning, yeah, if I can add a step or remove a step and so on. And then I say generate the journey map. And once I say generate the journey map, it is able to create a very, very clean visual of the journey map based on a template that I provided. As a product manager, I have defined that this is how the template or the diagram should look like, and and then um, ensure that the artifact is created in a very, very um, predictable manner. Now I can download this as an image, or I can download it as a vector file, as an SVG file, and so on. So um, the interesting thing is, if you want to make some changes to this journey map, you don't just prompt the LLM. You can be very, very deterministic about it. Okay, I want this online appointment booking to be called online appointment booking journey, and be very precise about it. And I want to add one step, saying this is a step that I'm signing off, and so on, and save it, and then generate the journey map, and then it creates a new step, and then I can download it. So as you can see, with the new capabilities of large language models such as Gemini and ChatGPT, a completely new set of capabilities are now available for product managers. And product managers should develop this AI product craft to take advantage of these capabilities. I hope that helps.